Space is freezing. The sun is millions of degrees. Both are true, and weirder than you think. The sun's surface burns at 10,000 degrees. The space between the sun and Earth is colder than minus 450 degrees Fahrenheit. And yet the same sunlight that crosses that frigid vacuum will burn your skin in 20 minutes. Space is cold. The sun is hot. The sunlight in between is neither. That sounds impossible, but it's exactly how physics works when there are no molecules. Temperature is not what most people think it is. It isn't a substance, and it isn't really hotness. It's a measurement. Specifically, temperature is the average kinetic energy of the molecules in a given volume of matter. When you touch something hot, what you're actually feeling is fast-moving molecules colliding with the molecules in your fingertip and transferring energy to them. A cup of boiling water feels hot because each water molecule is vibrating and rotating at extreme speed, slamming into your skin millions of times per second. A block of ice feels cold because its molecules are barely moving. This is why temperature requires molecules. No molecules, no kinetic energy to average, no temperature in the everyday sense. And that is exactly the situation in deep space. The vacuum between planets contains, on average, less than 1 atom per cubic centimeter. For comparison, the air you're breathing right now contains roughly 25 quintillion molecules in that same volume. Space is not so much cold as it is empty. With nothing to measure, the concept of temperature gets weird. You can't stick a thermometer into the vacuum and get a normal reading, because there is nothing for the thermometer to exchange energy with. Heat has nowhere to flow. Heat only moves in 3 ways, and 2 of them don't work in a vacuum. The first is conduction. That's direct contact, molecule to molecule. A hot pan heats the handle this way. Conduction needs matter touching matter, so in empty space, it does nothing. The second is convection. That's bulk movement of a fluid, hot air rising, cold water sinking, weather, ocean currents. Convection needs a fluid to circulate, and the vacuum of space has no fluid. So that mode is gone too. The third way is radiation. Radiation is completely different. It doesn't need any medium at all. It's electromagnetic energy, photons, traveling at the speed of light. The sun radiates this energy in every direction. Those photons cross the 150 million kilometers of vacuum between the sun and Earth in about 8 minutes, not interacting with anything along the way because there is essentially nothing there to interact with. The instant they hit your skin, your atmosphere, or a spacecraft hull, they deposit their energy. That impact is what we call heat. The space the photons traveled through wasn't heated because there was nothing in it to absorb them. Only when radiation meets matter does the matter get warmer. That single mechanism, radiation without a medium, is the whole answer to why space is cold and the sun is hot at the same time. You can see this principle in action on every spacecraft humans have ever launched. The International Space Station orbits at the edge of vacuum, with no atmosphere around it. The side facing the sun, lit by direct, unfiltered radiation, can reach about 250 degrees Fahrenheit. The side in shadow, just meters away, can plunge to minus 250 degrees. Same station, same vacuum, 300-degree swing across a few feet of structure. The only difference is whether photons are hitting that surface or not. To survive, the ISS uses giant radiators, flat panels that face deep space and dump excess heat as infrared radiation, the only way to lose heat in a vacuum. Astronauts on spacewalks wear suits with reflective outer layers to bounce radiation away and heating elements inside for the shadow side. As for space itself, it does have a baseline temperature, just barely. Photons from the Big Bang are still arriving everywhere, stretched into faint microwaves. That cosmic microwave background fills the universe at 2.7 Kelvin, about minus 455 degrees Fahrenheit. That's as cold as space gets. The Sun is 27 million degrees in its core and 10,000 at its surface. The two coexist because in between, there's nothing to be hot. That's why space and the Sun don't share a temperature scale. Subscribe to Curious Science for more questions where intuition fails and the physics still works. Tomorrow, why cold coffee tastes different and what your nose isn't smelling.